from the doubt box. We have a Telegram group, Takshzila Study Circle. Anyone can join it and ask doubts. In this series, we discuss some choicest doubts that have been asked in the group. So today we'll be discussing two questions. One, a tough question. Find the sum of this infinite series. The denominators you can see are in a GP, but the numerators are not in an AP. So you might be able to recognize the series. I expect you to do that. But in spite of knowing what the series is, solving it can be very tough. So do try it. And a second question, this is not a tough question. It's a pretty easy one as such, except that it is very tedious and time consuming. In fact, it is very deceptive. It seems that one can solve it very fast enough, but when you get into it, you will find out that it is going to take at least 2.5 more minutes. And the solution that we'll be discussing is a very nice use of ratios, which will reduce our time by 60, 70, 80%. Okay, so pause the videos, do try it. I'm continuing. So we are back to this series. So I'm assuming that you would know AGP, right? So if I talk of this series as S, and then there's a step in between that you do, you divide it by the R, or you multiply it by R, that is 1 by 7. And then you subtract, but you should be able to get to the direct answer. 1 minus, in fact this also you should write it as 6 by 7 is, this 1 remains, then 2 minus 1, that's a 1 by 7. 3 minus 2, that's again a 1 by 7 square, so things look good. 5 minus 3, that's a 2 by 7 cube. Oh, so it's not a constant, okay, but I'm getting 1, 2, 3. Then 8 minus 5, 3. Oh, so maybe now it is going to become an AP 1, 2, 3, but here I get 5 and not 4. 5 by 7 raised to 5, and this is going to be 8 by 7 raised to 6, and so on. So what was expected hasn't really happened, and that series that we had 2, 3, 5, 8, you can again see it here, 1, 2, 3, 5, 8. And for those who want the intermediate step, what we do is we divide this by 7. So this becomes 1 by 7. This will become 2 by 7 square, 3 by 7 cube. But I again repeat, this only adds to your time, and then you would be a little slow. And then when we subtract, that is where I wrote 1 minus 1 by 7. We'll be subtracting this, which will give me 1 by 7. We'll be subtracting these, both have the same denominator, so it is 3 minus 2, which is what I was doing. We'll do this, 5 minus 3, and so on. So some students would have done a little more tougher questions here and will say, hey, why don't we do that once again? So when I do that 2 times, this is 6 by 7, and of this again I'll get a 6 by 7. So here the 1 will remain as it is. This minus this, okay, so that is something weird. This minus this again, okay, so, and this minus this is 1 by 7 cube. This minus here is 1 by 7 raised to 4. This minus this will become 2 by 7 raised to 5. And here will again be 3 by 7 raised to 6. And while you might wonder, maybe 1, 2, 3 has started, not really. Had I done this next step here more, this was a 13 by 7, 6, this I wrote. Let's say here there was another term, the series, I guess you would have figured that out. This would have been a 34 by 7 raised to 7, and this would have been a 21 by 7 raised to 7. When you would have subtracted it here, we would have got a 13 by 7 raised to 7, and this minus this would have been a 5. So again that series of 1, 2, 3, 5, and the next will again be 8. So whatever you do, that series keeps cropping up again. So how do you handle this? Therefore I said this is a tough set, right? This is what was expected by you, at least you should have done it. Now the hint is, the series I guess you would have figured out is nothing but a Fibonacci series, though the first term is a little truncated. So 1 plus 2 gives you 3. 2 plus 3 gives you 5, 3 plus 5 gives you 8. So in this, any term is nothing but the previous term and the yet previous term. So this is the relation. Now watch out, yeah, this is interesting. How do you make a solution yourself? So you start with this and we say, okay, I have a number, let's take 8 now. So this series, this 8 is made up of nothing but 3 plus 5, okay? So this 8 and this. So this is the relation. So what if I subtract this? So if I subtract these, then I would be left with 0. That means that term will get cancelled out. Oh, so it's I need to subtract this 8 minus 5. So this is 8 minus 5 and a minus 3. I think so this is a good enough hint, students. Now you should take a pause and try it yourself. So I'm going ahead to save time. I'm finishing it off very quickly. So we have S. So what I'll do is I'll do S by 7. Okay, so this will be a 1 by 7, 2 by 7 square, 3 by 7 cube, 5 7 raised to 4, 8 is 7 raised to 5, 13 7 raised to 6, and so on. And I can get an 8 minus 5, but I also want an 8 minus 3. So I will divide S by 49 also, or a 7 square. Let me just put this as a 7 square. So S, when I divide by 7 square, the 1 will be divided by 7 square, 2 will become a 7 cube, 3 will become a 7 raised to 4, 5 will have a 7 raised to 5, 8 will have a 7 raised to 6, and so on. I don't need. And now what I'm going to do is, this is equation 1, this is equation 2, this is equation 3. I'm going to do 1 minus 2 minus 3 and see what happens. When I do the left hand side, we'll handle it later, or I'll leave this out for you to find a better way to write this directly. Here the 1 remains as it is, so we'll take up the denominators, we'll take like denominators. So we'll be subtracting this, and here 7 square, 7 square, 7 square. We'll be subtracting this, and we'll do this, and we'll do this. So since the denominators are equal, we can directly subtract them, and so on. So we have a 1 which will be as it is. Then we'll have a little outlier, 2 by 7 minus 1 by 7. Okay, and here onwards, if you look, 3 by 7 square minus 2 by 7 square minus 1 by 7 square. Obviously, you're not going to write it this way. And if you do this, this is going to be 5 by 7 cube minus 3 by 7 cube minus 2 by 7 cube. And so on. This 8 will be 5 and a 3, which is what we had analyzed and thought about this idea. So all these will cancel out. You might argue that this is going this way, this way. So end there is going to be some terms that will remain here. But then this is a GP, right? So these are infinitesimal, very, very small. Similarly small. So that we can ignore. So we are talking about the series will converge, and will converge to what? So obviously you can do the left hand side now, and this is what remains, rest all cancels out, right? So very nice, tough question, little twist to the AGP part that we know. Okay, next question. So two people, Neil, Nitin, had a certain number of marbles such that the difference between them was 15. Okay. So the problem is this is a difference. So I do not know who is more and who is less. So first Neil gives Nitin 2/5 of marble he has. Then Nitin returns 3/8 of the marble he then has. Okay. And the ratio number of marbles which each is them is same as they originally had. Find the number of marbles. So looks good enough, just a transfer. But when you start it this way, Neil and Nitin, Neil has X. Now Nitin has how much we do not know. Is it plus 15 or minus 15? We do not know even so, and this can really derail the whole thing. You know, you might make a wrong start and then you might end with a absurd result and then you'll not know what happens and you'll have to redo it. So now when he transfers something, how much does he transfer? 2/5. So he'll be left with 3/5. Even if you use some intelligent things like assuming this as 5x, it's not going to help you too much. A very minor help will happen. And now he will have x plus 2/5 of x. And even if you're very fast there, 1 plus 2/5 is 7 by 5. Oh, 7 by 5 of x plus 15. Okay, and now he is going to return marbles. How much? 3/8 he will return. So he will be left with 5/8. This itself, I am saying, is a very efficient way that you're progressing, but the whole approach is going to be time consuming. And now here you would need to add, he had 3/5 of x plus he gets 3/8 of what this guy had, right? And so here the tediousness starts. And what do we do after this? After this, it said the ratio at the start, okay, is same as the ratio at the end. So you'll have to write that in this format, and you will have to do the, you know, open out the brackets, find something. You are going to get into a quadratic. You will have to factorize the quadratic. Options are not there. You try some plugging values, won't work. So it is very time consuming. And not to forget that we might end up with we do not know what was it. Was it x plus 15 or x minus 15? And look at this now. If I consider it is just a transfer between the two, think about the logic, yeah, what you need to catch when you think transfer between the two. So when I take them as a group, when I consider them together, then no marble goes out, no marble comes in as a system. It only goes from Neil to Nitin, Nitin to Neil, but not outside, together, okay, nothing. So what that means is the total number, that is what this together says, total number remains same. Okay, and the total number remains same and is divided in same ratio at start and at end. The ratio is same. Oh, so what that means is each has same at start and at end. So whatever Neil had at start, that is what he has at the end also. Think it has to happen. Some people struggle with this. There's a total number of marbles. If that has to be divided in the ratio 3:5, randomly I am saying, then the first will get 3/8, the other will get 5/8 of it, and the total is same. And even at the end it's the same, so it has to be same. So, and if each has the same at start and end, means whatever number is given by Nitin is same as the number that he receives. That is the time when he'll have the same thing, na? So what does he give? He gives away 2/5. 2/5 of whatever Neil had, he gives him. And what does he receive? He receives 3/8. 3/8 of what does he receive? Now watch here, student, it's not as easy. While your brains must have started working and there must be some excitement, but it's not easy to finish it. In fact, pause it and try to finish it yourself. Okay, anyway, so here we'll continue. It will whatever Nitin has plus whatever Nitin receives. Receives from whom? From Neil. Neil has given him. You can write 3/5 of Neil also. You can do that, but hang on for a minute. These two are equal. And now don't try to make it into an equation. If you make it into an equation, the whole idea fails, what we are trying to learn. Yeah, ratios are very good. So could I say that the ratio of what Neil had to the ratio of what Nitin plus whatever Nitin receives, could I say this ratio is nothing but 8 2s are 16, 5 3s are 15. Okay, could I say this ratio is 15 is to 16? Think this is a part which is the key part that we are learning here. Okay, so this is 15 is to 16. You could say this is 15k and 16k. And do not forget that the 16 is nothing but the 16 is whatever Neil had at start plus. Okay, let me take a k and then do it. So this is 15k and 16k, and the 16k is whatever Nitin had at the start plus what he receives. And what did he receive? He received 2/5 of this. So could I say he receives 2/5 of 15k? And this all you should try to do it orally, students. So 5 3k 6k 6k he receives, then it becomes 16k. So from here, can you change the ratio to whatever Neil had and whatever Nitin had at beginning? That is nothing but he had 15k and this guy had 10k. So straight. And that is the difference, 15. 15 is the difference. So it's given that this difference is 15. So k is nothing but 3. Okay. And if k is 3, Neil had 45, he had 30. I'll leave it for you to do the transfers and see that it fits in. 30 will be my answer. A beautiful way, and which really, saves a headache of all this equation work. So if you have a doubt troubling you, or you want some insightful solution of how do we use a ratio in a particular situation or so on, please join the group Takshzila Study Circle on Telegram, post it there, and we'll meet another episode with some more doubts. Thank you.